刚刚忘记自我介绍，我是今天早上 Keynote 的主持人，我叫 Renata。今天早上由我来为大家做一些引言，请大家多多指教。接下来呢，是我们刚刚有提到远从日本来的贵宾，Mr. Tagomori。日文的话，我们会称呼他为 Tagomori-san。那他来自于一个非常有名的公司，大家的手机里面一定都有他们的产品，那个公司叫做 Line。那今天 Tagomori-san 要为我们介绍说，他们如何利用 Hadoop 在 Line 里面解决一些问题。我想我会废话比较多对不起，因为我们有很多精彩的演讲，所以早上是不休息的。那如果各位有需要休息、需要厕所的话，请自己安静的从旁边。那女厕在这边，男厕在这边。好，请大家就是安静的利用。那我就不要多说什么。Ladies and gentlemen, please welcome Mr. Tagomori.
Hello. Good morning, everybody. And I am very surprised that in Taiwan's morning is very early, and and many developers and arrived here. Yes. Sorry, I am very nervous that this talk is This talk is the first keynote talk in my life, and this is the second English talk in my life. So, but I try to do my best. But then Taipei is very great city. I think that very wonderful experience. I experienced very wonderful dishes and buildings and many Hadoop and developer community and developers. Today, I will talk about data analytics platforms and its softwares and middlewares and platforms and architects and paradigms and my idea that I created to solve many problems and we are using in the backend of Line and data analytics platforms. I am Satoshi Tagomori, and also known as Tagomoris. Tagomoris is my account name of Twitter and GitHub and other many services. And I am an open source software developer and Fluentd or Norikra or Shib or many others. And I am living in Tokyo. And I am working at Tokyo, and also working at Tokyo in Line Corporation. Line Corporation have several branches in many cities worldwide, and also in Taipei. And we are trying to build a new developer team in Taipei branch, and the lead engineer have just joined our branch as a developer leader of developers. And so Taipei is a very important city for us and for Line Corporation as a developer and community and for these developer communities and also very great users of our service Line. Line is born about 3 years and several months ago, and now Line is become very major big messaging service in several areas of world, including here, Taiwan. Okay, and I have two questions. And who knows Line? Who knows Line? Oh, everybody knows Line. Thank you very much. And one more question: who uses Line? Oh, fantastic. Thank you very much. And everybody in Taiwan, everybody uses Line. That is very great. And not all Japanese uses Line, so Taiwan is greater. Taiwan is the greatest area for us. And Line has now Line have hundreds of million users in worldwide, and Line is handling 10 billions or more messages per day, and that is very huge service. And we are using very many software products in backend of Line, and for example, Redis or HBase. HBase is very big, very important product for us, but I cannot say about the Line message communication service backends because I have no time. So I will talk. And on the other hand, we have many sub-services and side services and online platform like Line Manga or Line Camera or Line News or Line Q or Line More or many others. And many of these services are served in Japan, and some of these services are also served in Taiwan. And moreover, we have many game applications on Line platform like Line Disney Tsum Tsum or Line Pop or Line Pokemon or many others. And so, and for our Line developers, we have many services, so we must handle many types of roles and many kind of metrics and many kind of KPIs, and also we should analyze these many services status and by analytics of many kind of it's a huge amount of data. So we should try to build the better data analytics platforms. So, and there are many data analytics workloads, like reports or real-time metrics. So, yeah, and reports, and we require many types of reports, and monthly reports or daily reports or weekly reports or many others. Of course, and we are using Hadoop on these workloads. And moreover, we are producing hourly or more shorter news reports, and for to manage and daily service and changing or daily service to change better our services and in short period. And real-time metrics is also important for automatically updated reports or graphs to see how our services are used and how traffics are how traffics our services have, and moreover alerts and alerting for abuse of services and overalls are very important to manage our many services. Of course, and so, and I will describe these workloads and related software and one to one. Okay, yes, I'm very sorry that and he is not in our sticker lineups, but I want his sticker, but that is impossible. So, yeah. As Hadoop, and for batch processing, and Hadoop is very important software, and Hadoop MapReduce or Spark or Tez, and its DSLs, like Hive or Pig or many others. And we are producing many kind of big amount of reports by Hadoop MapReduce and Hive, and we are mainly using Hive. And moreover, recently we are using MPP engines like Cloudera Impala or Apache Drill or Facebook Presto, and yes, and we are mainly using Facebook Presto, and for interactive analysis and for reports and shorter time windows, like hours or minutes or more shorter. For interactive analysis, and these MPP engines are very important for for these days, and we are using Presto and heavily by handwriting queries or through over BI2 and business intelligence tools. And on the other hand, stream processing. Stream processing is very important. Stream processing and middlewares exist like in Apache Storm. Apache Storm is now an Apache incubator project, and that is written, developed to realize and distributed and fault-tolerant real-time computation. But Storm requires many computers and many steps to deploy. So, and we are not using Apache Storm in data analytics platforms on data analytics platform. In different places of our backends, and we are using Storm, but I don't know in details about these usages. And also, Norikra. Norikra is written by me, and it is realized and non-distributed and stream processing with SQL. With SQL is very important for us, and I will describe the details of Norikra later. Okay, and what stream processing we are using? Stream processing makes these merits like rest latency. Rest latency is very important for real-time metrics and shorter-term prompt reports. So, and the data now just arrived are make effect to the graph, and now we are viewing. That is very important. And less computing power. And 10 megabit per second data for batch processing means 10 megabits per second average data becomes 100 gigabytes per day. That is relatively big data for one server or one computer or two or more smaller computer. And we need Hadoop or any other distributed processing platforms to process 100 gigabytes per day. But we can process by only one server as stream, 10 megabit per second stream. That is very important, and we can process this data as stream by only one server. Of course, it excludes and high availability or other problems. But less computing power is very important. And no query schedule management. And if we need the reports per 5 minutes, and in batch processing systems, and we must execute queries every 5 minutes, and we must watch these queries status, and after finished, and we collect these results. But and moreover, if these queries failed, and we must retry these queries. This is very complex procedure. But with stream processing, once the query registered, and it runs forever, and we can collect these results automatically. That is very. That makes report generation very easier. Okay, but stream processing has some disadvantage. For example, query must be written before data. So in stream processing, the order of procedure is once the first we write queries, and second the data is arrived and processing are executed. So we cannot run these stream processing on past data. So, and we should, there should be another way to query the past data, like Hadoop or Presto. And queries cannot be run twice. Yes, and if any error occurs and all results are lost, and we cannot rerun these queries. And if any bugs exist in our queries and all data have gone, and we cannot correct twice. And disorders of events, and so this is relatively difficult to describe, but if we want to generate and make reports and for specified 5 minutes, the first event arrives, and this is the starting point, and the second event arrives 3 minutes later. That is the second event, and the third event arrives at 6 minutes later. Okay, this is 6 minutes later, and this event is out of our 5 minutes window. That is very simple, but if we want to handle timestamp and with recorded time, and many events have a timestamp, but the record disordering is may occurs frequently rather than we expected. So the older event arrives later later in some cases. So, and we cannot use a recorded timestamp and for stream processing in many cases. So arrival time-based queries are different from batch query results. So, and this is a relatively difficult problem to solve. So, to solve these problems, we have a Lambda architecture. Excuse me. And Lambda architecture is firstly said by a Twitter engineer, and this is this description is written on lambdaarchitecture.net. An important point is the needs for a robust system that is fault tolerant both against hardware failures and human mistakes. That is this. So Lambda architecture Lambda architecture makes us to rerun queries. That is very important. And for hardware failures and human mistakes. This is overview of Lambda architecture, and Lambda architecture has 3 layers, and mainly batch layer and serving layer and speed layer. And once we write in queries, and that query is served on a serving layer and speed layer. So, and new data arrives. If new data arrives, and that data is written on both of batch layer master dataset and speed layers and real-time view. So, and once we write just one query, and same data processing are executed both on serving layer, batch layer, and speed layer. So, and we can use data as mainly on speed layer, and if any errors and failures or mistakes occurs, we can show the query results of serving layer and batch layer. That is core point of Lambda architecture. So the Twitter summing bud is typical, typical and most favorite framework for Lambda architecture. And Twitter summing bud have a batch mode, and batch mode is based on scalding on Hadoop MapReduce and real-time mode on Storm. And we can write summing about queries on in Scala or Java like this code. This code is word counting by Twitter summing about in Scala code. That is very great innovation for data analytics workloads, but So, what Lambda architecture provides is replayable queries. Replayable queries makes us to enable to redo queries anytime if results of speed layer are broken. That is very important. And moreover, we can get an accurate results on demand for the previously described arrival time and recorded time problem. And we can get prompt reports in speed layer with arrival time, and later we can get fixed reports in batch layer with recorded time of events. And of course, we can get many more benefits of stream processing by Lambda architecture platforms. But why all of us don't use it? Sorry. Who uses Twitter summing about? Oh, no one knows Twitter summing about. Thank you. And why all of us don't use it? And Storm problem. The reason of one of the reason is Storm. Storm doesn't fit well for many use cases. Storm requires many computer resources too big to deploy for many users or many service companies. And moreover, summing about requires many steps to deploy. So that is very complex and difficult steps to deploy. So many of data analytics engineers cannot use Twitter summing about. And moreover, many directors and analysts or marketer don't write Scala or Java. So Twitter summing about DSL is not enough easy to write for these people. And if the marketer wants any reports on Twitter summing about, an engineer must write these queries. That is very hard to manage and to continue to use these platforms. And I think that the queries must be able. I think that the marketer or director or analyst for non-professional people can write these queries. That is yes. So I create a bit different platform. That is Lambda architecture using SQL. Yes. And using SQL is very important for many people, of course, including engineers or marketers or service directors or data analysts. Okay, and this is a traditional Hadoop platforms of us, and we are using data collector. We are using Fluently as data collector, and Fluently writes and event data on Hadoop HDFS. And we are using Hadoop Apache Hive and Facebook Presto to query these data. That is very simple production platform. But we want to stream processing platform, so I wrote Norikra. Norikra is a schemaless stream processing and server software with SQL. Yes, and then Norikra is an open source server software and provides stream processing with SQL written in JRuby, runs on JVM, and open source software licensed under GPL v2. And this SQL is a Norikra query, one of the Norikra query, and this is very simple. And select path and pass select count of and status 200 or status and 500 or all of events grouped by path. But a bit difference exists with a dot, win, and time batch 10 minutes. By this specifier, we can execute this SQL for every 10 minutes time windows. And we get the results every 10 minutes. So I just added the Nulicra on this platform. And frequently copies and input events and write these data both on HDFS and Nulicra. And query, and we are writing Nulicra query separately and runs on Nulicra. This is very simply added on our Hadoop platform. Okay, but this is not exact Lambda architecture platform, of course. And we are writing different queries on each software. But this query above and Hive query is this Hive query and processes data and just as same as this Nulicra query. These are almost same queries, I think. And both of those queries are very, okay. Those of both queries are very easy to write for many people and for many developers and for many data analysts. And SQL dialects are there are already many SQL dialects in this world, and standard SQL and Hive and Presto in Drill. And I've just added the more one dialects Nulicra query. And we can easily write these SQL queries twice for one processing, like this, or like this. So this is, of course, not exact Lambda architecture platform, but we can use this platform, and we can manage this platform. Okay, we are using in many use cases for data analytics, but for example, one of these examples is in reports, prompt reports for ad service. And prompt and ad service requires very short-term periods and reports for their customers. So we cannot run Hadoop MapReduce per 1 minute. So we are using Nulicra to produce short-term prompt reports. And also we are using Hive to produce daily fixed reports. And the other example, summary of application server error. Oh yes, application error logs are many application error logs are generated on some troubles. So we aggregate these error logs for routing by Nulicra, and not all of error logs are notified. And one of these error logs, the typical one error logs of many amount of data are alerted, are notified on engineer's console. So then, if engineer receives that an alert, they can investigate this error on Hive or Presto or any other traditional graph or any other methods. Okay, and I will talk about these details of these use cases in the first session of this afternoon. Okay, and wrap up. And this is Team2D. Team2D is a power programming language model, and that means there's more than one way to do it. Of course, it means Lambda architecture in here. So we can of course, we can use the exact Lambda architecture, but of course, we can take another way to get these benefits, like this Lambda architecture using SQL. So we should think about any other way to do it always. And this is the last page, and this is my motto, and share what I want and what I'm doing. What I want is, of course, in Lambda architecture and its benefits, and what I'm doing is what I'm talking here. But this motto, and I believe that this motto makes the world better than ever, I think. Okay, thank you for everybody.
大家有没有什么问题要问我们塔公玻璃上？机会难得，预购重述，请各位。あと10分。後ろ。だいぶ早く。
Hello. すみません。Okay. That's all the Japanese that I can speak. Okay. I'm wondering that how do you use the streaming process to in the such like data sorting? Like if I use the SQL language, like select something and I hope to sort the data, because as I know that the streaming process, the data is always coming, so you cannot view the whole data. So how do you do that?
Is your question is about the heavy traffics? How I handle the huge traffics of data? Is your question?
Hmm? 他是说，所以你是要问他说他是怎么利用 stream 去处理他的 data？
对，怎么去收听他的 data？
你要问 sorting 吧，对不对？
对。
How you sorting？
是问 sort 还是问怎么处理？
就是
听不到，不好意思。
Okay, I know. The question is sorting, and sorting is very difficult problem. But I do not sort the events on stream processing platforms, and so because of it, and the stream processing query results includes some difference from the sorted data query. That is what I described this page here. Yes, disorders of events, and we actually we are sorting an event on batch layer. On batch layer, and we make partitions of events by the recorded time, and so we can sort events, and we can sort these events and rewrite another pattern of the sorted pattern. But on stream processing, we cannot do sorting. So we are using arrival time. Arrival time is the timestamp of the Norikra when Norikra receives these events. And sorting is a very hard problem on stream processing, and we decide that we do not sort these events.
Thank you.
Yes. Any other questions?
还有其他问题吗？前面
Hi, I have a question about that Lambda architecture, and we know that we have a batch layer and we have a speed layer. Okay, then I'm interested about how could you integrate and merge both of them and become to another insight? Would you
how much are these results from batch layer and speed layer on insights?
Yes.
And you can, yeah, okay. That okay, and that is also a very big and difficult problem, I think. That, but then the merging of result, the way to merge and the results are different between our services. And one service does not merge these results and usually using recurrent results. And eventually, if any troubles like network troubles or query bugs, then runs queries on Hive or Presto and use these results. On the other service, they are using recurrent results for today's report. Today's report means the reports from this morning and 0 o'clock to 23 o'clock. But the very early morning, like 2 a.m., and they run a Hive query and get and fix data, fix query results, and update all of previous days and reports by fixed reports. So the different service engineers take another way and take another way to fit another way, and that fits for their use cases. So and merging way is different for different for users or usages and their cases. So I cannot determine the just one merging way. So I talked each and service engineers and how much and we should how much we wish we should these results data. Okay, do you understand?
Okay, thanks. Because a batch layer means that the process may be prolonged, maybe one day.
Oh, sorry, pardon?
Yeah, I mean the batch, the Lambda architecture in the batch layer is longer. I mean the data may be the one day, but the speed layer may be per second or per minute. So that means both of them, the quantities are different. So I'm interested about, based on this different, how do you combine the data with one insight?
Yes, the difference exists, and we cannot the difference cannot be solved. So okay, okay, and we have no time, so that is very difficult problem, and I cannot explain here in this short time. So let's talk later and after this or keynote sessions. Okay? Thank you.
Thank you. 不好意思，各位，就是因为我们时间已经到了，那 如果就像刚刚先生有问题的话，只要各位在会场捕捉到野生的 Tagomori 上，都可以直接跟他讨论问题，没有问题。那下午也有他的一场演讲，会讲解的更 detail， 欢迎大家参加。到时候在时间允许范围内，尽量问题轰炸他，没关系。好 ，Thank you very much, Mr. Tagomori. Thank you. 好。非常感谢大家的大力支援哈。那个真的有问题的话，今天2位日本讲者是非常难得来到台湾，那他们在日本的 Hadoop 界也是非常活跃的人物。他们在今年 Hadoop Japan 也